Hello families, it's me, Miss Dominique. Today we're going to be comparing fractions with like numerators or like denominators. Today we're going to be focusing on like denominators. Here's the problem for the quiz. Haley is comparing the length of her necklaces. Her yellow necklace is 1 6-foot long. Her blue necklace is 4 6-foot long. Her green necklace is 3 6-foot long. What order should the necklaces be in if they're lined up from longest to shortest? Prove your answer with visual models or number line. The first thing I think about is, are the holes the same size? So they're all necklaces, and they don't really say like one is a fat necklace, one is a small necklace, so I'm going to assume all the holes are the same size. The next thing I need to think about, are my numerators the same or my denominators the same? I see my denominators the same. Let me think, what does that tell me? The denominator is the number of equal parts in each whole. So that means that each necklace has the same number of equal parts in the whole when you think about it as a fraction. So if I know that they have the same number of equal parts, that means I need to look at the numerator to compare them. If you have more parts we're talking about, that means you're going to be longer. So without even drawing a model, I can already figure out what's the longest and the shortest necklace. So I know, since they all have the same number of total pieces, the more pieces you have means you're the longest. So that means the blue necklace is the longest because it has 4 6. It's 4 6. It has 4 of the equal parts, and that's the most parts of any of the necklaces. And I know the yellow necklace is the smallest because it has 6 equal parts too, but it's only talking about one of them. So I know that the blue is the longest and the yellow is the shortest. Now I need to just prove it with a visual model. I already started here with a visual model. I partitioned it into 6. First I partitioned it into thirds, and then use what I know about doubling to partition each third again to make 6. Now I'm ready to show the fraction. This is 1 6 and this is the yellow. And I'm just going to shade in 1. And then I have the blue necklace, which represents 4 6. 4. And I'm going to shade in 4 to represent 4 6. And I can already see the blue is way longer than the yellow. And then I have the green necklace, and it represents 3 6. So I'm going to shade in 1 2 3. So based on this, I know that the longest necklace is the blue necklace. Blue necklace, which equals to 4 6, is greater than the green necklace, which equal to 3 6, which is, green necklace is greater than the shortest one, which is the yellow necklace, which is equal to 1 6-foot long. And I know this is true because when I look at my visual model, I see the largest fraction is going to take up the most amount of space in an equally sized hole. And I see that the blue fraction, all the holes are the same size. The blue fraction, the blue necklace, 4 6, is taking up way more space than the other ones. And the smallest fraction is going to take up the least amount of space in the equally sized holes. And we see 1 6 is taking the least amount of space in the visual models. This is the simplest strategy to compare fractions. Improve your answers. Some scholars may try to use number lines, but if they're struggling, push them back to using visual models to really prove and see the equivalencies.